my N3 cuties, good day. Let's start this lesson of module 3. So I'm going to share my screen and then we go to the notes which I've shared with you. Okay. So module 3 is all about forces. And when it's comprised of two topics. The first topic deals with coplanar forces. The second topic deals with frameworks. So for the first topic, this is what we must know when we complete this topic. We must be able to resolve the forces analytically into horizontal and vertical components. So we did this in N2 where they would give us an oblique force and they would say we must resolve it into its two components. So a force will have a vertical component and a horizontal component, or a parallel component and a perpendicular component. Then 3.2.2 says we must calculate analytically the sum of the horizontal and vertical components of a system of forces acting on the same point by using the following equation. So you can see here that to calculate the horizontal components, you're going to use cos, meaning all your angles, you must use the angle that the force makes with the horizontal component. And to calculate your vertical components, you're going to use sine, which means your vertical component must be opposite to the angle for you to use sine. Then 3.2.3, calculate the magnitude of the resultant force as well as calculate the direction of the resultant force. Then determine the direction of the equilibrant. If you've got the resultant force, then it's the same magnitude with the equilibrant, but it's the opposite direction. Determine the direction of the equilibrant from the principle that the directions of the resultant force and the equilibrant differ by 180 degrees. So it's the direct opposite. Determine the magnitude and direction of an unknown force by applying the principles in 3.2.1 to 3.2.4. Okay, I might leave out this part for now and come back to it as a different lesson. So in N2, we learned how to resolve a force. For instance, this is an 80 Newton force. It's acting 50 degrees away from the horizontal plane. So I'm just going to do a quick recap of that N2 lesson. If we had to resolve that force, so it's an 80 Newton force, 80 Newtons, and it's at 50 degrees from the horizontal, acting downwards like that. So if we had to resolve that force, we would say, and at N2, we would need to calculate the vertical component as well as the horizontal component. So what you do, you sketch your two components. One component will be parallel to the plane. We said that in N2. Parallel to the plane, meaning it goes along the plane, and another component would be perpendicular to the plane. So we said if you do this properly, a right angle triangle will show up by itself. And then the one that is vertical, you name it VC for vertical component. And this one, you name it HC for horizontal components. Then the angle is here. I just wrote too big here, but the angle is here, that 50 degrees. And then to calculate horizontal component, because it's adjacent to the angle, you will say cos 50 degrees equals to adjacent over hypotenuse. Therefore, the horizontal component will be 80 cos 50 degrees. There you just do your maths. Okay. You just do your maths. So now let's do this maths. Calculator, where are you? Okay. There he is. So we want to know what is 80 cos 50. It is 79, 695. So 695, if you collect 3 decimals, becomes 696 newtons. Okay. But at N3, we're actually interested to this answer. We don't want to work it out. So I'll be more glad if you don't work it out. Leave it at that stage. So this is your horizontal component. And then to get your vertical component, because your vertical component is opposite to the angle, you will use sine. Sine 50 degrees equals to opposite over hypotenuse. Therefore, VC equals to 80 sine 50 degrees. Okay. So these are the answers that we're going to use now at N3. So when we looked at the formula, we said your horizontal will always be cos and your vertical will always be sine. But that will only be like that if the angle given is the angle that it makes with the horizontal. Like in this case now of that 120 Newton, you see that it makes 50 degrees with the vertical. So you'll have to change it and calculate the horizontal angle, which is going to be 90 minus 50. So it's going to be 40. So if you had to calculate the VC and HC of that one, you would have to, you say 120 cos 40 is the horizontal, 120 sine 40 is the vertical. You won't use that 50 because the 50 now it makes with the vertical. You want the angle that it makes with the horizontal. Okay. So then let's continue. So that was just a recap of the N2. And then if we look back at N1, we had to add up vectors because the whole purpose of this lesson, you will be given a number of forces and they want you to calculate a resultant force of those forces as well as the equilibrant. So in N1, we learned how to add up parallel vectors and get a resultant vector. Also, how to get a resultant vector for non-parallel vectors. So when you have parallel vectors, it means you have two vectors. They could be acting same direction or opposite direction, but they are on the same line. They are parallel because they are on the same line. So this is an example where you have, okay, let's just reveal everything because it's not doing the sequence I wanted. You've got a 7 Newton vector going east, and you've got a 30 Newton vector going west. To get a resultant vector, you'll have to say east is positive, west is negative. So that was N1. So we had to say 7 minus 13, it gave us a minus 6 Newton. So the negative sign tells us that the 6 Newton force must go west. So this was a resultant vector. So in N3, we're going to talk about the resultant force now, not the resultant vector, so which is the same concept. And then, remember in N1, when we had non-parallel vectors, you couldn't just say north is positive and east is positive. You had to sketch a parallelogram. From that parallelogram, you had to sketch a diagonal. Then that diagonal was representing the resultant. Because it's a right angle triangle, you could use Pythagoras theorem to determine that resultant because the red force here is also 7 newtons and this green force here and that one is also 13 newtons. So you could use Pythagoras to say the square root of 7 squared plus 13 squared, it gives you the answer that 14.746 there was obtained by using the Pythagoras theorem. So in N3, you're going to get a number of forces. Then you need to bring them down to two forces, one Y force, one X force. The Y force is called the vertical component or the sum of the vertical components. And the X force is called sum of the horizontal components. This is the simplest form that you're going to get at N3. From this, the question will say determine the resultant. Now, the same information we used in N1 applies, where we said north is positive, south is negative, east is positive, west is negative. So to get a resultant of these, first get the resultant of the vertical forces and get the resultant of the horizontal forces. then those two resultants will give you the actual resultant. Okay. So the horizontal resultant of the horizontal components is called sum of the horizontal components. This is what I call the X force. The one force that represents all the horizontal components. So that force will be east is positive 13, west is negative minus 18. It gives us minus 5 newtons. The negative indicates it's going west. So you write there. If it's positive, it's east. If it's negative, it's west. That is now for horizontal. Then for vertical, north is positive, south is negative. North is upward, 21 minus 6. We say minus for 6 because it was facing down, it's negative. It comes as a positive 15. If it's positive, it indicates it must go northward. If it's negative, it must go southward. So you write the direction also there. Then to get the resultant of these two, remember now the 5 Newton is your X force and your 50 Newton is your Y force, your vertical force. So you get a resultant of those two. If you were to sketch them, they would look like this, minus 5 newtons. I'm going to show you shortly. And then, 15 newtons. If you were to sketch them, they would look like this. They would look like that, minus 5. That's why we make it face this way, because it's negative, and 15 newtons. Then your resultant would go like this. That's your resultant. Hence, we say to calculate your resultant, you will say square of a resultant equals to square of the 5 plus square of the 15. Then to get rid of that, you square both sides, and then that cancels that, and then R will be equals to the square of 5 plus the square of 15. It gives us 15.811 newtons. So this is just the resultant. And then if they want the angle, if they want you to determine the angle, let me just see on the notes if the formula for the angle is given. Okay, they didn't give the formula, but it is on the formula sheet. Okay, so let me take a quick look at the formula sheet. Let's just find the recent formula sheet here, just so you can see what I'm talking about, that the formula is given here. Okay. Okay, here is the formula. So the formula says that tan theta equals to sum of the vertical components divided by the sum of the horizontal components. So which means that angle is here. It's always this angle, okay? Because tan theta equals to opposite over adjacent, okay? So second function 10 is gonna give us what? 15 divided by 5, 71.565. 71.565. Okay. So this is how you calculate your resultant and the magnet, the direction. So you will say here it's 71.565, and what is the direction here? It's north of east, northwest. Your vertical is north, your horizontal is west. Okay, so those stands for that. Okay, so that is the simplest one. You're gonna get at entry where you just have 4. Okay. And it's very rare to get it that simple, but the idea is the same. You first have to find the one force that represents all your vertical forces by saying upward forces minus downward forces. Then you find your one force that represents all your horizontal forces by saying eastwards forces minus westward forces. Then the answer you get for each, you use that answer in Pythagoras theorem to calculate the resultant. Then you use that answer again in that formula that says tan theta equals to sum of the vertical components of the sum of over sum of the horizontal components. You use that to calculate your angle, the angle of your resultant. Then your equilibrant is the same magnitude, it just acts in the opposite direction. What do I mean by that? If your resultant is here, it means if this is your resultant, it means your equilibrant is here. Okay, so your equilibrant is here. So it's the direct opposite. Okay, so if you use the same angle, then you will say southeast for your equilibrant. It's going to be the direct opposite. Okay, so let's continue. Let's look at a more complex one. Now, like I said, that one is a simple one. At times, they will give you forces that are at an angle, not forces that are just vertical and just horizontal. But your goal is to first resolve the forces so that you have them vertical and horizontal, because only then you can get your resultant force. So in this case, okay, this force was not supposed to show now. So only these three forces are given. They have 8 kilonewton acting 60 degrees away from the horizontal. They have 4.5 kilonewtons acting 45 degrees away from the horizontal. Just remember, I said if they give you the angle that it makes with the vertical, you don't use that angle. You calculate the angle that it makes with the horizontal to make it simple. So what you will do here, first take the 8 kilonewton force and resolve it so that you have a vertical component and the horizontal component. You're going to do the same with the 4.5 kilonewton force. You're going to resolve it to a vertical component and a horizontal component. So let's look at it. So these are the components of the 8 kilonewton force. It's 8 cos 60 and the vertical component is 8 sine 60. Then the 4.5 kilonewton, these are the components of that force. The vertical component will be 4.5 cos 45. The vertical component will be 4.5 sine 45. So if you were to resketch it, it would look like that. Those are your vertical components, just the two of them. So vertical component of the 8 kilonewton force and the vertical component of the 4.5 kilonewton force. Horizontally, you have the black force, the 3 kilonewton. That one is already horizontal. You don't do anything with it. You just bring it along, as well as the horizontal component of the green force and the horizontal component of the blue force. Then you would do the maths. Some of your vertical components, both of them are positive because they are facing up northward. So you just add them together. If there was one that was facing south, you would subtract it. Then you do the same with your horizontal components. You add these two, the 3 kilonewton and the horizontal component of the green force, because they are going east. But the one that is going west, you subtract it. Hence, you have here minus 8 cos 60. That is 60 degrees, not 600. I think the editing changed itself over time. So this is sine 60 degrees, cos 60 degrees. Let me see if I can quickly change it. To avoid confusion. I don't know why it jumped up now. Yes. So then you do the maths. You get your answers, and then you use the Pythagoras. You use the Pythagoras to calculate the answer here. Use Pythagoras to calculate also the answer there. No. You just add your answers here using your calculator. Then to get the resultant, you use Pythagoras. Okay. Now, this is the next example. Did I work it out also? Oh, seems like it's been worked out because I want us to do the book example. So again, here, the 635 Newton force, it's already vertical. You don't do anything with it. But the 350 Newton force and the 420 Newton force, you resolve them. So here's the vertical component of that force. Here's the horizontal component of that force. This is the vertical component of this force, and this is the horizontal component. This must be 420 here, not 420. Then so once you resolve them, you drop the forces and then you use only the components because components are representing the force. So there you have it now and horizontal. So you're gonna get your sum of the vertical components by saying this force plus that force minus the 635. Then you're gonna get your sum of your horizontal components by saying this force minus this force. We minus it because it's going west. Okay. And that's it. Let's take an example from the textbook. Okay. So we're gonna use this example. We're gonna use that example. So I have sketched the example here for easier reference. I'm going to show you shortly. So this is 40 degrees and that is 30 degrees. So let's look at it. Yeah. So what is the question? The question is calculate the resultant of the four forces acting on a point as shown in figure 3.5. So we want to calculate the resultant. So as we said there, the first thing you want, so this is already vertical and that one is already horizontal. But you want the vertical component of the 60 Newton force as well as the horizontal component. So the vertical component of the 60 Newton force will go this way. It will take the same direction as the force. Now, that is extremely important. I didn't mention the direction. The direction of your components must be the same as the direction of the force. If your force is going more left, then your horizontal component goes left. If your force is going more to the right, your horizontal component must go right. If your force is going more downwards, your vertical component must go down. If it's going upward like that, your vertical component must go up. So simply your components must take the directions of the original force. So this component is going to be, this is the 60 Newton force now, it's going to be 60 cos 40. And the vertical component is going to face down like that, is going to be 60 sine 40. And the horizontal component of this force is going to go this way because this force is going more to the left. It's going to be 45 cos 30. And the vertical component will gonna go up like that, and it's gonna be 45 sine 30. If I were to resketch this just to make it more clearer, I would have 55 newtons here. And then I would have the 60 cos 40, which is this one. And then I would have the 45 cos 30, which is this one. And then the 50 Newton force is facing up. I would rather do it here, this one, the 50 Newton. Another upward force is that one, the 45 sine 30. So I would sketch it up, 45 sine 30. Then downward, I have the 60 sine 40 coming down like this, 60 sine 40 degrees. Okay. So let's calculate. To get your resultant, the formula says it's the square root of sum of your vertical components plus the square root of sum of your vertical components. Okay, you can start with any one. So let's start with sum of the horizontal components. Some of the horizontal components I've got now a 55 Newton force. It's positive, it's going east. Then the 60 cos 40 is negative because it's going west. 60 cos 40. I subtract it. And then the 45 cos 6 cos 30 is also negative because it's going west. I subtract it. 45 cos 30. Then from there, I get an answer. Very important how you use your calculator here. Open your brackets to put in the 60 cos 40 because sometimes if you don't put in the brackets, it misbehaves. Then the next one is minus 45 cos 30. Also open the brackets. So it gives us a negative 29,934 newtons. Because it's negative, we say it's going west and we write down that west. Okay. So let me just quickly double check it because I didn't double check. I just wrote the first answer that came, and that is not wise. You must always double check your answers just to make sure I'm getting the same answer, so I assume it's correct. So some of the vertical components will say, what will it say? It's gonna say the upward forces minus downward forces. If you want, you can write that formula, but it's not necessary. So this is eastwards forces minus westwards forces. So this one is upward forces minus downward forces. As long as you know if it's upward, you add. If it's downward, you subtract. If it's east, you add. If it's west, you subtract. You don't have to write this part of the formula. So upward, we have 45 sine 30 plus 50. Downward, we have 60 sine 40. So we subtract it because it's downwards, okay? And we bring in the calculator. So we open the brackets and we put in 45 sine 30 plus 50. Icona. What did I do? 45 sine 30 plus 50 minus 60 sine 40 something is not right here. Okay, let me say 45 sine 30 first minus 60 sine 40 equals to plus 50. I am getting 33.934 newtons. That's positive, it's going north. So vertical will be north or south, horizontal will be east or west. And then to get my resultant, I'm going to say the square root of 29.934, I square that, 33.934, I square that. So you notice I left out the sign because the sign is basically just to show you the direction. You don't need to put it in here. But even if you do, you won't change anything because you square it anyway. Plus 33.934. You square that. And then it gives you the resultant of 45,24998, which is 45,25 newtons. You can put that northwest, but then you actually need to calculate the direction. So we said tan theta, that formula says tan theta is sum of VC over sum of HC. So tan theta, so theta equals to second function tan of VC. What's your VC? 33, 934 divide by, what is your HC? 29,934. So you put in your calculator, second function 10. So it knows that it's going to put it on top. 33,934 divide by 29,934. And then it gives us an angle of 48,584 degrees. Now we can say north of west. North of west. Okay. So this was an example. Am I right? Okay. Was an example. So here is their answer, 45,249. We have 250, and then the angle is 48, So that is the whole concept of the calculating a resultant force of a number of forces. So you can go to the question papers and you can do more. So let me end this lesson here. Then the next topic will be frameworks.